All right, let's take a look at page 19. Now here it says object A is thrown upward with a speed of v naught. Okay, so here is object A, and is thrown upwards with v I y of A to be v naught. Okay, so obviously this thing's going to go up and then it's going to come back down. Boom, right? And we all know at the maximum height, right, we know that v f y max is 0. Good. Then we also have yb, or a ball B, and this ball B is actually thrown twice as speed as, so v I y of ball B is twice the v naught, 2 times the v naught. Okay, and of course this will also go up in the air and then it's going to come back down, and your v f y max for ball B should also be 0. They want to know how much higher this ball B will travel compared to ball A. Okay, well, we can work this out separately and just compare afterwards. Okay, so let's take a look at what happens. Since we have vi, vf, we have a sub y, right? We have a sub y, which is equal to, right, negative 10 meters per second squared for both A and B, right? So we can use the third equation, right? So this is for ball A. Let's see, this is ball A, okay? And we have VFY max squared is equal to VIY squared plus 2AY times Y final minus Y initial, right? Well, we know that Y initial for both are going to be zeros, right? So here, we know final velocity at y max is 0. So 0 squared. And initial velocity for VIY is V naught. So we have V naught squared plus 2 times negative 10 times y final minus 0. So y final minus 0 is just y final, right? So 0 is equal to V naught squared minus, this is negative 20 times y final is negative 20 y final. If I bring this negative 20 y final to the other side, I get positive 20, right? Y final is equal to V naught squared. So my y final comes out to V naught squared over 20 as your height this ball A will gain. Okay. Well, let's take a look at what happens to ball B. Okay. Same thing, right? VFY max squared is equal to VIY squared plus 2A sub y times y final minus y initial, right? So here, 0 squared is equal to, right? This time, my VIY for ball 2 is twice the V naught, squared, okay, plus 2 times negative 10 times y final minus 0. So here, when I square the 0, I get 0. When I square this whole quantity inside, I get 4 times the v naught squared, right, minus 20y final. So if I bring this to the other side, I get positive 20y final is equal to 4 times the v naught squared. So my y final for my ball B is equal to 4 times the v naught squared over 20. This v naught squared over 20 right here is same as your y final A, right? So this is same as saying 4 times the y final of ball A, because this is the y final of ball A. So the ball B will travel 4 times as much than the ball A. Yeah? Are we okay with that? Okay. All right. That's good. So let's take a look at number 7. 2 objects are dropped from a bridge. Okay, 2 objects are dropped from a bridge. So let's visualize it. So here's the bridge. Okay. It's a trestle bridge. Okay. And object A is dropped 1 second before object B. So which one travels first? A. So A is dropped 1 second before, right, before B. So B is going to be like following, right, A. Okay. Both velocities when they started out were 0. So this is like, you know, y initial is equal to 0 for B, and y initial for ball A is also 0. And since they were both dropped, my vi of A is 0, and my vi of B is also 0. Okay? So that's pretty much what's given to us so far. Then, 6 seconds after the second object B was dropped. So which time is that? 6 seconds is for time for object B, right? Then what is the time for object A? 7 seconds. So that's good to know. Okay. So how far apart are the objects? So what does that mean? They want us to figure out what is the separation between object A and B, right? Okay. After object B falls for 6 seconds. So, well, let's take a look at what happens. So here, your object A, or ball A, has fallen this far, and then your object B has fallen maybe this far, right? So they want to know what the separation is. Okay, they want to know what is the separation between the two when this is 7 seconds, right? And this is, oops, wrong color. This is 6 seconds. Okay, that's what they want to know. Yes?
Why is the line
because they were both dropped. Well, we want to keep it at wherever it starts, because we don't know how high it is. Do you know how high it is? No. That's going to be our starting position, right? Yeah. So and then if it goes up, it's positive change in position, or if you go down, it should be negative change in position. I mean, that's a good question. It's a valid question. That's a good question. So you can make your zero anywhere you really want. You know, if you know the building is so many meters high, then you could consider the ground to be zero. Then you could keep that building to be like a positive height, right? But if you want to keep that building, top of the building, to be your zero, then whatever you fall down from the building is going to be negative y position. But that's up to you. That's up to you. But keep it easy for you. You know, that's why you label everything. Like, draw it out, label like where your zero is, where your initial position is, and so on. That will help you see things much clearer. Good question. All right. So here, let's take a look at ball A. Let's take a look at ball A. Okay. Now, ball A, it has traveled for 7 seconds. So we know initial velocity. We know A sub y is -10 for both balls, right? Or both objects, right? So we have all the ingredients for second equation. So we could say y final is equal to y initial, right? And of course these are all ball A for purple, right? Plus v I y t a if you want to write down all these subscripts, that's fine, plus 1/2 a sub y t a squared. Well, I want to know how far this thing falls for 7 seconds. Therefore, my y final for ball A is equal to initial, like we made that 0, the initial position to be 0, right? So 0 plus initial velocity for y for ball A is also 0 because we dropped it, plus 1/2 times -10 times t A is 7 seconds. You have to square that. So if you work that out, your final position for ball A is equal to, after it has fallen for 7 seconds, happens to be -245 meters. So at this position right here, your y final A is -245 meters, which means it has fallen down from our 0 starting point to downward direction 245 meters. So we know the position of that ball. What about for ball B? For ball B, my y final for ball B is equal to y initial of ball B plus v I y of ball B TB plus 1/2 a sub y TB squared. Wow. So now we plug and chug. So my y final for ball B is equal to, initial position for ball B is 0, and initial velocity of the ball B is also 0, plus 1/2 times -10 times, here is 6 seconds squared. Okay, 6 seconds squared. Therefore, if you work that out, my y final for position for ball B is equal to, God bless you, -180 meters. Thank you. All right. So now we know the position of the ball B after 6 seconds, and position of the ball B for 6 seconds right here. All right. So y final for ball B is equal to -180 meters. All right. So we know these two positions. So since we want to find out the separation between the two, all we have to do is, you know, subtract the two, right? So we can say the separation is equal to simply, you know, the absolute value of YFA minus the absolute value of YFB, right? So the separation is equal to, I mean, separation really cannot be negative. You just want the distance between the two, right? So here you could say 245 minus 180. So your separation is equal to 65 meters apart. So this separation is 65 meters. Is that okay? Now, what would happen if I, instead of drop it, what if I threw it? What would be the difference between these two? Like, what would change? Huh? If I throw it up, it'd be positive VI, right? If I throw it down, it would be negative VI. Does that make sense? Since we dropped it, it was 0. But if we were to throw it up or throw it down, then we would have either positive VIY or negative VIY, depending on. Okay? Does that make sense? All right. All right. Moving along on page 20. For page 20, we have another balloon problem here. Yeah. So here, a balloon is going upwards at 16 meters per second. So our initial velocity will be the same as the balloon's velocity if we were to drop something, right? So this is 16 meters per second. At height of 32 meters above the ground, a package is dropped. So you're dropping from a moving platform. So the initial velocity of this ball, so VIY, is positive 16 meters per second. When your Y initial position is 32 meters. And if it hits the ground here, now your Y final is equal to 0 meters. Alright, Lydia, now you see, right, now we know the height, so we make the height to be whatever, and then we'll make the ground 0. Alright. They're asking for part A, what is the velocity of the ball? Now, very, very careful here. Velocity. They want the velocity, so it has to have direction too. All right? Instant before it strikes the ground. So they want to know what this velocity final is. Right here. Right before it hits the ground. All right? So for part A, we could probably use, you know, we have VI, we have delta Y, we have A sub Y, which is negative 10 meters per second squared, right? So we could probably find the VF, we could definitely find that using equation number 3, because I don't have time, right? So let's write everything down that we know. So we know Y initial position is 32 meters, right? We also know Y final is 0 meters. We know VIY is 16 meters per second. That's positive 16. We know A sub Y is equal to negative 10 meters per second squared. We're looking for VFY. So again, we have no time here. Therefore, we can use equation 3, which is VF y squared is equal to VIY squared plus 2AY times y final minus y initial. So this is same as delta y, okay? So y final is what we're looking for, so VFY squared is equal to VIY, which is positive 16 squared at, plus 2 times negative 10 times y final is 0, minus VIY is, YI is 32. Therefore, my VFY squared is equal to, 16 squared is 256. Here I get negative 20 times negative 32 is negative 640. No, positive 640, because negative times negative. Therefore, this whole thing should come out to 896. So if I take a square root of it both sides, my VFY is equal to plus or minus square root of 896. However, since they want the velocity of this ball going down, which one do we pick? Positive or negative? Negative. Right? So we should pick negative 29.9 meters per second. All right? All right, so that was easy. So for part B, they want how much time does it take to hit the ground? So they want the time now. Well, we know everything here, don't we? We could use the exact same variables that we know, but this time we also know my VFY. So for part B, we can use my VFY is negative 29.9 meters per second. We know VIY is positive 16 meters per second. We know A sub y is equal to negative 10 meters per second squared. I can find time using equation number 1, which is VFY is equal to VIY plus A sub y t. VFY, negative 29.9, is equal to 16 minus 10t. Now notice what would happen if you did not put negative 29.9. Right? You would have gotten a negative time, because you'd be dividing that positive value by negative 10. So if I bring this 16 to the other side, it becomes negative. Now I get bigger negative is equal to negative 10t. So now we divide both sides by negative 10, and you get your time to be positive 4.59 seconds. Are we good? All right. All right. Let's take a look at the last problem. Number 9. Number 9. Number 9. All right. A sandbag is released from an air balloon traveling downwards at 6 meters per second. It's traveling downwards at 6 meters per second, so the moving platform has negative 6 meters per second velocity. And the sandbag is released. Therefore, my VIY of the sandbag, okay, is equal to negative 6 meters per second, which is exact same as the moving platform. All right. This is your Y final, which is 0 meters. We don't know what your Y initial is. We have no idea. We do know it takes 7 seconds to hit the ground. And my A sub y is equal to negative 10 meters per second squared. They want to know what height was the sandbag dropped from. They want to know what your y initial is. So if we write down everything we know, we'll start with VIY being negative 6 meters per second. We know A sub y is equal to negative 10 meters per second squared. We know time is equal to 7 seconds. We know y final is equal to 0 meters. We're looking for y initial. Looks like we could use equation number 2 because we don't have v final. So we can say, y final is equal to y initial plus VIYT plus 1/2 a sub y t squared. Well, we know y final is 0. We're looking for y initial plus negative 6 times 7 plus 1/2 times negative 10 times 7 squared. So 0 is equal to my y initial minus 42 minus 245. So your y initial starting position happens to be 287 meters. And this 287 meters is measured from above the ground, right? Yesterday, when we were working on this very quickly, we did not finish this problem. So I just want to finish this off. Is that okay? All right. So we did part A, and we also did alternative part A. So now we can focus on, let's take a look at what happens for part B. Alright, so part A is done. Part B, how much time will the ball be up in the air is what we are supposed to find out. So for part B, this thing is going to start from here 80 meters above the ground. It's going to go all the way up, stop instantaneously, and come back down to hit the ground right here. Alright? Therefore, we can say y initial is equal to 80 meters. Y final is equal to 0 meters. VIY is equal to 40 meters per second. My A sub y is equal to negative 10 meters per second squared. And my time t is what we're looking for. So, if you were to use the second equation, y final is equal to y initial plus, right, VIYT plus 1/2 a sub y t squared, plug and chuck. Y final, 0. Y initial, 80. VIY is 40. Plus 1/2 times negative 10 times t squared. If I were to write this in a descending order, I would have negative 5t squared plus 40t plus 80 is equal to 0. This will make this A, right? This is A, this is B, and this is C. Right? So if you use your calculator and use the quadratic formula, right, you'll get T total is equal to either 9.66 seconds or negative 1.66 seconds, and obviously time cannot be negative, so you need to pick the positive time, which is 9.66. And then for part C, what is the ball's speed when it reaches the bottom, right? When it reaches the ground? Well, we want to find basically VFY, right? Because that's what we're looking for, this VFY, right? And this VFY is what we're looking for. We know VIY, which is equal to 40 meters per second. We also know T, which is 9.66 seconds. We know A, which is negative 10 meters per second squared. So we can use equation 1, which is VF is equal to VI plus AT. If you want to put the Y subscripts, you can do that. So my VFY is equal to 40 plus negative 10 times 9.66. So my VFY comes out to, well, 40 minus 96.6 should give you negative 56.6 meters per second. Well, that's the velocity, because it's going down is negative, okay? However, since they want the speed of this ball, right? So since they want the speed, your final speed in the y direction is basically 56.6 meters per second. Speed is always positive. All right. Now we have completed everything. Yes. Yeah, it was wrong. What happened was Doc used this number here instead of 40. That's what happened. So this answer given right here, and yesterday I like rushed through and I just used the answer that Doc had, but it was 56, so it should be 56.6 meters per second. All right. Any questions? All right then. I'm going to give you about 5 minutes to organize everything, and then when you're ready, pass up your note packet, and then put your phones in the sin bin over there, and then I'll give you your quiz. All right?